Hi, this is the Magitron team. I'm Zach,
I'm Dan.
and this is what we have for you this week.
Okay, so our design description is pretty much the same as before. It's a real-time sound modulator. It takes audio in from a microphone, applies audio processing effects, and outputs that altered audio in real time. Our one change is that instead of the speaker being on the user's body, it will now be in the room. The specific effects are going to be selected by the user through a companion web app. The audio effects we're looking at so far include equalizing, echo cancellation, pitch bend, filtering, boosting, and reverb.
So what we accomplished for milestone 3, we got our first working prototype. We successfully had audio streaming from our microphone to our speaker with good quality, and we did manage to achieve a pitch shifting audio effect as well. But we did run into some snags with noise problems.
In terms of the website, it is complete with a REST API and a front end. Previously, it was only the back end, only the HTTP server responding GET and POST requests from the Postman API reader. But since then, we've added handlers attached to buttons on the website, so it is complete now.
And what we're looking to do for milestone 4, and what we've already accomplished, is we fixed the audio quality. Our audio library is now working, and we have a successful pitch shifter without any noise working. And that's what we've accomplished on the physical side.
So for the website, we actually want to change the way it works because right now it works through a loop which actively drains power. So rather than doing that, we want it to be asynchronous. So we're using the async ESP library to do that. We also want to add our website files to the ESP SPIFFs file system for ease of use and a cleaner workflow. Right now, the HTML, CSS, and JavaScript is all kind of embedded in an Arduino sketch, which is annoying to work with.
And another thing we're looking to accomplish in our next milestone is to increase the number of audio effects that we can use and also increase the variability of them so that the user can change them. And we're also looking to hopefully finalize our form factor and design our final PCB in the upcoming week so that we're able to compact our design and get it looking and functioning the way we want to. So the design changes that we've made lately is the first one, the speaker will no longer be on the user's body. It's too easy for feedback to mess with the quality of the sound. And so what we're doing is, as Dan said, we're implementing an ESP32 to receive audio data and output it to the speaker using the ESP Now protocol, which is a Wi-Fi. Yeah, Dan will talk about that.
So as of what we learned, mostly just the ESP Now protocol. It's a low power wireless protocol made by Expressive. It can work with Wi-Fi. It can communicate between ESPs and can do one-to-all or one-to-many communication. We had an interview also where we asked about specifically what do we want the website to look like and what we want the final device form factor to be like. The interviewee chose the simplest website options possible, which was just like buttons on the phone screen that have whatever effects we have, and it just toggles on and off. Also, in terms of the form factor, he preferred the clip-on where the device clips onto your shirt or jacket or whatever, as opposed to the headset.
And so our final questions that we have for you, if you were to use our product, how would you like the user interface to be structured to allow for multiple audio processing effects and allow you to control them? And our second question is, what kind of physical filter would you use on the microphone to prevent excess noise in the input signal? And that's all we have for you today. Thank you.